Is La Nina weakening and fall starting? I am Mark Sponsler, and welcome to the Storm Surf Videos Surf Forecast for the week starting Sunday, August 25th.
Storm surf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you liked the video, give us a thumbs up. If you haven't subscribed, click the Storm Surf icon down in the lower right-hand corner of your screen. That'll get you all signed up, and you'll get automatic notifications when the videos are posted, typically on Sunday evenings. If you have a question or concern, write them up in the comments section down below. We'd be happy to answer. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Alex, Kim in California, and then our longtime contributors, Tim Caston, Evolution Moto, and Elliot Harris, all well represented this week. And then our big donator for the week, and a good large donation at that, Craig. Thank you so much. I really appreciate it. All of you, I do appreciate your contributions. And with that, let's get to work. We'll start by looking at significant wave heights, not just for the Pacific Ocean, but for the entire planet. And we have it's kind of busy. It's kind of a mixed bag, but we'll just go through it. We'll start in the South Atlantic. Small gale with 24-foot seas targeting South Africa. Another gale in the South Pacific with about 25-foot seas, not really aimed anywhere good. Another series of gales with 26-foot seas in the Indian Ocean, and a series of tropical systems strung across the Pacific. The tropics actually surprisingly busy, considering La Nina is supposed to be developing, hence some of the discussion around the title of this video. We'll get into the details on all these starting now. But first up, let's take a look at current conditions. We'll start by looking at the buoys. Point Reyes buoy up in Northern California, 029. Not a whole lot going on here. We're looking at all the energy that's hitting this buoy, all the way up from 33.3 second period, super long, very energetic swell, if there was any, which there is none, 0.0 feet, the whole way down to 5 second period, just pure wind chop. We see a little mix of stuff in the 14, 13 second range and some more minimal wind swell. You put all this together, primary swell 1.4 feet from 13.4 seconds from 276 degrees. This from a tropical system previously that recurved off of Japan on a supposed La Nina developing year. That's pretty rare. And made it to the date line. Small swell though. I mean, we're talking like, well, it says surf height 1.8 feet. That's about what it is, thigh high right now. Secondary swell 1.7 feet at 9.3 seconds from 234 degrees, but that's really more like wind swell. And it too is very small in size. Then we go down to Southern California, the Point Loma South buoy off of San Diego, buoy number 191. Same sort of profile, a little bit of background energy in the 14 second period range, and then basically no wind swell at all. You can see it here. Primary swell 1.4 feet at 13.4 seconds from 243 degrees. That's getting wrapped around a little bit by the Channel Islands, but that is that same really a northwest swell. I don't know that any of it's even rideable in Southern California. And the secondary swell, 1.7 feet at 5.9 seconds from 278 degrees. That's 1 foot. I mean, there's maybe some waist-high waves somewhere, but not a whole lot going on. And then we go to the south shore of the Hawaiian Islands. We're looking at the buoy at Lanai, number 239. You do see a bit of activity here, some sort of spike in the, we'll say 10-second range, that from a tropical system passing south of the Hawaiian Islands as we speak. Primary swell 3.4 feet at 10.4 seconds from 171 degrees. Calculated surf height 3.5 feet. I saw sets that were waist to almost chest high, almost no one out, and the wind's offshore, so it's sort of sneaking in, getting in under the radar. People are not on it, but there are waves. So I've been busy this week working on wave models, and I am proud to announce that These new big format wave models are now available for everyone. We'll get into how you can get to them in just a second. But we're going to start here by looking at the hindcast for the South Pacific. What's been going on the past week? Chile, Peru, New Zealand, Australia, Antarctic ice, Ross Ice Shelf here, Antarctica proper. A little bit of a gale developed southeast of New Zealand. There was this other gale with 35-foot seas, but they were all aimed southeast, offering nothing relative to California or Hawaii. But then as we got into Monday, this is the 19th of August, we're going back a week, little gale developed producing 26-foot seas, and I think it built right there to 28 feet. Small swell, there you go, into almost Tuesday morning, the 20th of August. Now, there were higher seas, but again, they all started taking aim on the Ross Ice Shelf and the Antarctic ice, doing nothing. So small swell from that system is radiating northbound in for Hawaii and California, but small is the operative word. We're now into Thursday and Friday of this past week, and not a whole lot happened after that. Pretty quiet pattern, and there we are currently with, and also notice this here, we'll put this, you can literally see, I'll go back here, and there you go, watch right in here. I was able to incorporate the algorithm that calculates where the highest seas are over the entire domain and the highest winds. Not super, maybe I'll work on the font color here, but it is there. Now this hindcast stuff goes back 2 weeks. I just got this on the models starting Friday, 2 days ago. So if you go digging back in the archive, you won't see it, but for the past couple of days, it is there. All right, so where can you find these models? If you're on the Storm Surf website, you go Models, Wave. You just click it, and that gets you to this page here. You scroll down. I know there's a lot here. Hemispheric wave models, high-res surf forecast tool. No, full screen high-def wave models. The little colored icon is the forecast. It goes out 1 week. The white square is the hindcast. It goes back 2 weeks for both the globe, North Pacific, South Pacific. You got it. You can figure that out. They are big images. They are not little ones, but they look gorgeous. Even on a phone, or if you have a big monitor, they really look a lot better. They're like full HD 1080 width, or actually 1380 width images and 1080 pixels high. So if you have a TV, you could actually, and you get the website on your TV, you could get a full screen there. Then we'll do the same thing for the South Atlantic Ocean starting the 18th of August. Little gale passed under South Africa. Another one falling kind of southeast. Yet another developed along the coast on Thursday. But you see, not quite as prolific. This was probably the last good one here on Friday. I assume that swell is pretty much already hitting South Africa as we speak. Jeffreys Bay is like somewhere right over here. We'll get into that in a minute. Anyway, Saturday into Sunday, you get the general idea. Definitely waves, but not as big as what it has been the past month or so. And then the Indian Ocean, same deal. We'll run through this real quick. Again, not quite as prolific a pattern, a little bit of pause in the action. Still, decent seas. I mean, in the 36-foot range, aimed off to the northeast. That was on Friday, the 23rd of August. But, the season is starting to wind down a little bit in the southern hemi. All right, so let's go take a look at the forecast. We're going to start in the South Pacific, since that is our home base. We are looking at jet stream level winds. These winds are up about 30,000 feet. They help support the formation of gales, and when those gales form, help direct their track. We're looking for a trough, a push in the jet to the north. There is the northern branch, which doesn't do a whole lot to support storm formation, but it is the southern branch right here. And this is Antarctica down here. Chile, Peru over here, Australia, New Zealand, you get it. We have a bit of a trough here, winds pushing to the north. That helps create a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure, and of course low pressure generates winds. Winds get traction on the ocean surface, start imparting energy to the ocean and stirring the ocean up. That generates seas. Those seas start radiating away from the fetch area as the weaker lesser period elements of those seas start fading off, they expose the longer period elements, also known as swell. Of course, swell when it hits your beach turns into surf. So we have a trough southeast of New Zealand, but there is not, I mean, it's 70, maybe 80 knot or 60 to 70 knot winds pushing up to it. You really need at least 110 knot winds, so really not a whole lot happening there. As we get into Tuesday, a trough is forecast developing, pushing to the north here. Well, I'd call this over the south central Pacific. There's also a ridge, though, sweeping down with a split jet stream, northern branch, southern branch. All that does is create high pressure, but maybe there's a little hope right in here starting Tuesday, the 27th of August. But the trough quickly pinches off, doesn't do a whole lot, and instead we're left with this big ridge just pushing across, and the big split jet stream pushing across the Pacific, really doing nothing. We'll just roll this thing right out. Again, the jet displaced way south, the ice line's like at 65 north, and really just not a whole lot happening there in terms of support for storm production. So next we take a look at surface level pressure and surface level winds. We have 40 knot winds. They're almost aimed southeast. Another little area, 35 to 40 knot winds. Really just nothing particularly impressive indicated here. You really want to see 45 knot winds aimed off to the northeast. Now, a broad gale is forecast pushing under New Zealand as we get into Wednesday, the 28th of August, but most of this energy is all falling south, kind of cut off from the main Pacific window. Remember, the jet is pretty much split here. Not good upper level support to support gale formation. There's more fetch, all aimed to the southeast. Nice little gale here, but that's probably over ice, and this is on almost a week out, Saturday, a week out. Another gale pushing under New Zealand and pushing under Australia as we get into Sunday. We'll see what that does, but it too looks, you literally see it falling southeast and just getting squashed as it enters the Pacific Basin. So then we look at the forecast going out a week. These are the significant wave heights for the South Pacific Ocean. You see the ice way up here, almost at like 63 south. You see a series of gales pushing across here with 24, 26, 28-foot seas, but all just aimed due off to the east. Really needs to push north. Here is a gale midweek with 24-foot seas aimed off to the north, but it just fades off. Just nothing really getting any good traction. And here we are on Saturday, the 31st into Sunday. We are a week out, and nothing really of any interest forecast for the South Pacific. But then we look at the North Pacific. We're going to start by looking at tropical system number 1, number 2, maybe a third one out here, maybe a fourth one over here south of Japan. We'll just put this in motion. The current system pushing south of Oahu right now. It is, I believe, barely hurricane status, if not tropical storm strength. We'll take a quick look at that in a minute. And another one behind it, we'll just run the animation. You can see the one off Japan gets landlocked. The other two build behind, heading towards Hawaii, but look and behold what we see here. This is on Wednesday night, the 28th of August. 22 or 23-foot seas building to 25.9 feet. Let's go a little bit further, 27 feet, and that's about all we get. Still pretty far away from the Pacific Northwest down into California, but certainly capable, if it develops as forecast, of producing a maybe 15-second period swell pushing into the U.S. West Coast north of Point Conception from a very north angle. I mean, the cutoff relative to Northern California up here is like, I think it's like 306 or 307 degrees. So, and the tropical systems, they push north of Hawaii while getting weaker, and then really nothing behind that. So the model's teasing at maybe something. I wouldn't believe it, because this only showed up on the model, this run, the 12Z run of the model, and we'll see whether it even lasts another run. But at least it is a hope and maybe a hint that the North Pacific is going to start waking up and pick up the slack from the South Pacific basically being asleep now. All right. First tropical system, the one passing south of Oahu. It is a hurricane. Its name is Nome. It has, you can barely see it, 70-knot winds, so that's, just slightly above hurricane force. And it's actually south of, we'll say, roughly Maui right now. But it'll be east of Oahu by later this evening, and then heading off and fading off to the east from there. Whatever swell Oahu is getting, that is going to be it right now. Get it, or that's the end of it. The one behind that is Hurricane Gilma with 100-knot winds. Multiply that times 1.15. That's nautical miles per hour to get miles per hour, so 115-mile-an-hour winds, and pretty much at its peak. Forecast slowly fading. The Big Island's over here. It is a long ways away. Yes, there probably will be some swell on exposed east-facing shores of the Big Island, maybe up into, somewhere in here, but I'm not even betting that. It's a long ways away. And then Tropical Storm Hector has formed with 40-knot winds even further east of the Big Island. Forecast to never even make it to hurricane status. 55-knot winds at its peak. What is that? 2.5 days from now, so Tuesday evening, something like that. And then fading down at barely tropical storm status and still a long ways away, multiple days from now. Probably nothing going to happen with that. And then hurricane, or I guess it'd be a typhoon in the West Pacific, Sham Sham, south of Japan right here. Forecast to make a direct hit with winds, says up to 110 knots, so 125 miles an hour. This would be on the 27th, so 2 days from now. Tuesday morning, pushing over the South Islands of Japan and then fading from there, probably getting shredded in the mountains, and probably nothing to result from that. The folks of southern Japan are on alert and getting prepared for impact. All right, so let's go look at the significant wave height forecast for some other locations. South Atlantic Ocean, we're just going to run through this real quick. There is a reasonable storm, very small. Again, Jeffreys Bay is like right here. You see, what is that? 33-foot seas forecast almost directly impacting the area, and more energy down below that. So some sort of raw swell will likely result. But after that, it seems like a much quieter pattern is forecast. For the South Indian Ocean, now a little bit more interesting pattern going on here, starting right about there. Now notice that is a significant wave height of 40 feet, but again, aimed at Antarctic ice, not aimed up to the north initially, with seas building to 42 feet, and then starting to lift northeast, targeting Western Australia, and to a certain degree exposed islands here in Indonesia, but from a very south angle, and then that system fading out as we get into Sunday, and we're a week out. All right, so what's all this mean in terms of surf? Well, in the Pacific Basin, we know things are pretty quiet for now. There is a gale forecast for the North Pacific, but that's a ways out. For the short term, for the next week, surf heights, maybe 3 feet as we get into Wednesday, and most of that just wind swell. We'll go look at the actual swell heights here. 3 feet at 9.7 seconds. There is some southern hemi swell supposed to be trickling in here in the latter part of the week, but size is so small it's just going to be buried under the whatever wind swell there is, and there isn't even that much of that, so that's not saying much. Dana Point, Southern California, surf heights down in the 1 to 1.5 foot range. Swell heights 1 foot or less, though here is this bits of this southern hemi swell supposedly coming in 0.8 feet at 14 seconds, 0.8 feet at 13 seconds, so again, probably not even noticeable. We go look at Oahu, South Shore. Here is says 4.9 feet. Here is the surf height. That is as of Sunday right before sunset. And then you see surf heights just dropping off after that. All this from the tropical system Nome passing south of Oahu. Swell heights, 5 feet at 10 seconds. That's probably a little bit overstated, but after that, things pretty quiet. Jeffreys Bay on a roll with supposed surf of 45 feet. Now it's going to be a blown out mess. You can see the wind gauge is just pinned. It won't even go any higher. 40 knot winds out of the straight offshore. Which is probably almost side offshore relative to Jeffreys Bay. Then surf heights fading from there. Swell heights 30 feet at 14 seconds. That's right in the middle of the storm. So that isn't really swell. That's just victory at sea. Then we go to Bali. Surf height supposedly 14 feet as we get into Tuesday, fading from there, maybe popping back up again to 10 feet as we get into Friday, and then another little pulse on Sunday a week from now, with pure swell 8.8 at 16 seconds, and then bumping up again 6 feet at 14 seconds on Friday, and then bumping up yet again 7 feet at 15 seconds on Sunday. So that seems like the place that's going to get the award for the best surf and rideable surf for the week. And not to forget the hiker's forecast, the intersection of Pacific Crest Trail and Tioga Pass Road in Yosemite Valley. I really bring this up because you can barely see it here. This is the freezing line. This is the elevation from 14,000 feet down to 500 feet and temperature at all those elevations. There was freezing temperatures up at Palisades Tahoe at about 8,000 feet. There was freezing temperatures and snow on the ground Saturday morning, maybe 3/4 of an inch of accumulation at 9 a.m. By 10 a.m., the temperatures had warmed up, the snow turned to rain, and it was all gone. But the first official snow in the Tahoe region was recorded, and I don't think it was really, you'd have to get up higher when you get further south down to Tioga Pass Road in that area. Anyway, the forecast, temperatures, well, still trying to warm up, 45 degrees we'll say today, but by Monday, Tuesday, we're back into the 55 to 60 degree range. Now another little dip of coldness may be seeping in Wednesday, 10 days from now. It's not this Wednesday, a week from then. But even that, given the model, this changes radically from day to day. So I don't think that's really believable. But anyway, pleasant temperatures for backpacking or hiking. The mosquitoes are all gone, I'm sure, by now. And this is probably the last hurrah the next couple of weeks. So if you're into that, go get it. All right, let's go take a look long term. Let's look at the two major weather oscillations that affect the potential for developing storms or supporting storms and surf. The MJO, the Madden-Julian Oscillation, and ENSO, our favorite, the El Nino Southern Oscillation. We start by looking for signs of the active phase of the MJO, the first part of the discussion about the Madden-Julian Oscillation. There are two phases to it, the active and the inactive phase. The active phase is our friend. It is like a low-pressure system. The inactive phase is a high-pressure system. The MJO travels west to east around the planet. The active phase on one side of the planet, the inactive phase on the other side. They rotate west to east around the equator. When the active phase moves into the Pacific, because it's a low pressure system, it cuts or dampens the normal high pressure system that's over the Pacific, both north and south. And what it does is, because it's low pressure, it takes warm, moist air down at the ocean surface, lifts it aloft up into the atmosphere. That warm, moist air energizes the jet stream. And when you have a stronger jet stream, you get troughs, you get storms, and you get surf. At least that's the theory. The exact opposite happens when the inactive phase moves into the Pacific. Because it's a high pressure, it couples with the pre-existing high pressure system in the Pacific that generates trades, strengthening the trades, cutting off the flow of warm, moist air aloft. It's downward falling air, high pressure is, cuts off the flow to the jet stream. The jet stream gets weaker, it splits, sort of like where we are right now. And you don't get good support for storm development. That doesn't mean you can't have storms during the inactive phase of the MJO. And also, the active phase of the MJO typically supports tropical storm development. So you notice, when we were looking at the tropical section, 3 storms approaching Hawaii. Just based on that alone, I would guess that the active phase of the MJO is over the East Pacific. And then sort of looking west, I don't know. I would say maybe the inactive phase over there, but we'll get into all that in a minute. But we're going to start by looking at trade winds, because trade winds are an indicator of whether the active or inactive phase is in the Pacific. This is data from the TAO buoy array, a series of buoys strung across the equator in the Pacific used for monitoring El Nino, but there are wind sensors on there. We look at 5-day average winds, not winds for an hour or 2 hours, but over a 5-day period, are they stronger or weaker than normal? All right, so this is the East Pacific, West Pacific here, that's the equator, 180, that's the date line, that's New Guinea there. We're just looking at the arrows. These suggest pretty strong, the longer the arrow, the stronger winds, trades out of the east, so pretty strong over the East Pacific, pretty strong over the Central Pacific, and I'm waiting for this section of the array to come online. It took maybe a month or more for this section. This was down for a while. Now it's up. You notice 1, 2, 3, 4, 5, 6, 7. You see a lot more arrows indicating a lot more buoys up and running. Okay, winds strong. I'll say moderate out of the east here. Now, it's not the actual wind speeds that matter. It is the anomaly, difference from normal for this time of year. And lo and behold, we look in the East Pacific. We don't have many arrows because there isn't a lot of data available here. But what we do see is pretty much neutral trades, normal for this time of year. Again, in my mind, indicative of maybe the active phase over here. And then you see as we get to the date line, trades start picking up a little bit stronger than normal. Same thing over in the West Pacific. So the forecast, 850 millibar zonal wind anomalies for the next 2 weeks, and with at least a month's worth of backlog here of hindcasts. All right, these are the east-west component of the winds. The yellows, oranges, reds are westerly anomalies, roughly associated with the active phase of the MJO. The blues, the inactive phase, easterly anomalies, stronger than normal trades, weaker than normal trades. So you can see in July, August, into about, just about 3 days ago, westerly anomalies, the typically associated with the active phase of the MJO. Oh, this is the whole planet, sorry. So let's go. The date line runs right up the middle. The Pacific, California's at 120. Ecuador is about 80 west, so right there. Okay, the far West Pacific starts about 125 east, so right there. So you can see this looks like the active phase moving out of the Pacific towards the Atlantic. If anything, this would suggest maybe the Atlantic hurricane season will start waking up in earnest, while the inactive phase and easterly anomalies are building, and over the next 3 or 4 days, forecast to get quite strong, a strong, we'll call it an easterly wind burst, taking over the bulk of the Pacific and until about the first week in September, and then maybe some westerly anomalies start working their way into the West Pacific. Next up, 2 weeks forecast, outgoing long wave radiation, just fancy words for cloud cover. If you have lifting moist air associated with the active phase of the MJO, that moist air is going to hit the upper atmosphere, get cold, condense, produce clouds. That would be blues, which would be the active phase of the MJO. Yellows are falling air, cloud-free skies, inactive phase of the MJO. South America, Central America, New Guinea, EQ is the equator, date line right there. This goes out, each panel's 5 days. This goes out roughly 15 days. So basically a very, very weak MJO pattern according to this model, going completely neutral for the next 2 weeks. This is the statistic model. The dynamic model, in our favor, suggests active phase perhaps working into the West Pacific 2 weeks from now. Now notice, different models say different things, especially over longer periods of time. So we're trying to compare and contrast and divine in some way what the future is going to bring for us. Next up, phase diagrams. The same two models, statistic, dynamic model, just they pinpoint exactly where the active phase of the MJO is. How do you read this chart? Well, the MJO moves from west to east, from the Indian Ocean to the Maritime Continent, over the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is, so in the Indian Ocean, East Indian Ocean, we'll say, and the further this dot is away from this circle, the stronger it is. If you're on the circle or in it, it's considered extremely weak. No surprise from what we saw in the previous charts. And here is 1, 2, 3 forecast tracks having it moving to the maritime continent, and again, even weaker still per the statistic model. Now the dynamic model, look at this, suggests the active phase doing the same thing, but moderate strong over the maritime continent 2 weeks from now. That's an outcome that I'd like to see, because if it's strong over here, maybe it'll at least make it partway into the West Pacific at some reasonable strength before it collapses. We'll have to see on that. Now here is a statistic model, upper level, showing areas favorable for precipitation. Again, that, the active phase, taking warm, moist air, lifting it aloft, creating clouds. Now, because this is up at jet stream level, it runs about a week ahead of what happens at the surface, maybe even more. Anyway, South America here, Australia here, New Guinea here, equator there, date line running right down the middle. Clearly see the active phase of the MJO in this model making its way across the Pacific starting the end of August the whole way through September, and then into the Atlantic as we get later into the month of September. So different models have the MJO moving at different speeds and at different strengths. And then you see the inactive phase, according to this model, right now over the Atlantic and getting ready to move into the Indian Ocean, the 4th of September, and then over into the Pacific as we get later in September. This would be right here a time when there would likely not be much surf generation potential. If today we're right here and assuming this to be true, yeah, this might support some tropical activity, but it's kind of surprising that you get down here when supposedly the active phase of the MJO is building strong and there's nothing forecast on any of the charts. And you look at the east-west component of the wind charts, and they don't show anything going on either. So I think this is a bit overstated. All right, yet another model, a dynamic model, the CFS model. Again, east-west component of the wind. The reds are westerly anomalies, the active phase of the MJO. The blues, easterly anomalies, the inactive phase of the MJO. In fact, we have here MJO with a black contour. So the dotted contour, you notice the easterly anomalies here, inactive phase of the MJO. Here's the active phase. Notice some tropical storm activity. Now this is back in July, okay? This doesn't even have the current tropical activity that's going on right over in this area, probably being influenced more by the red here, an equatorial Rossby wave versus the MJO. So there are multiple types of waves that impact smaller scale tropical development, but the broader scale stuff like big winter storms in the north and southern hemisphere, really they're more dictated by the MJO. Anyway, you see here we are today. Dateline runs right up the middle of the chart here. The Pacific Basin starts at 125 west, so right here, 125 east here, and the main area to about 70 west, the Kelvin wave generation area right in here. You see nothing but easterly anomalies forecast for the next 1, 2, 3, 4 weeks. That's a month. Westerly anomalies try to make it into the Pacific about 2 weeks from now. They don't make it very far. They make it maybe halfway into the Pacific, and that's it. That speaks to probably the La Nina pattern. And then finally, the CFS model going out a month. Past performance here, the forecast here. The date line runs right up the middle. The blues, easterly anomalies, inactive phase, the MJO. The yellows, westerly anomalies, the active phase. But you see this like brick wall separating the two, and it's just continuous easterly anomalies, continuous westerly anomalies, with most of the westerly anomalies focused somewhere over the maritime continent or the Indian Ocean. This really speaks to a La Nina pattern in the Pacific, where the El Nino-ish type contingent of the cycle is over the Indian Ocean. Let's overlay the MJO first. All right, so here we are today. This is past performance down here. I'm just going to ignore it. The date line right here. Dotted contour, inactive phase of the MJO, according to this, solidly in control, and forecast to hold on the date line for about the next week and a half. And then inactive phase moving east of the Kelvin wave generation area, with the active phase of the MJO trying to make a push into the Pacific. You see it make it the whole way across the Pacific over the 3-month run, but you notice the westerly anomalies never make it any further east than about 150 or 160 east, so not even to the date line. Again, this speaks of the La Nina pattern, so let's just go look at it right now. The low pass filter. So what is this telling me? Now, there's actually good news here, and this is part of what I was referring to in the video about La Nina developing. Let's see if we can see it right here. But it is the forecast weakening. Okay, and this is the first little hint of it we see. So first off, the solid contour here, low pressure bias. I'll call it the El Nino signal. Last year, the low pressure bias was in the Pacific. That was our El Nino in the Pacific. It has now moved over the Indian Ocean. So El Nino, if you want to call it that, is in the Indian Ocean now. And you see high pressure try to get organized here. This was the La Nina signal, but as of right now, it's just gone. And what's even better news is it's not expected to start building again until beginning of October in any sort of magnitude, and then with only one contour. And every run of the model or every couple of days, this line here where it's supposed to start keeps pushing further out into time. The first little indicator that maybe our La Nina is not going to come as strong as we hoped or had thought it would, and maybe, well, I don't even want to say it, but for right now, I mean, typically, as you get into October and November, the peak of La Nina is typically right around late November into early December. Right now, this is looking like a nothing burger. And this is just but one of many models that are giving us some clues, and we're going to just take a look at all of them here in a couple of minutes. All right, what's going on subsurface in the ocean? Okay, El Nino, La Nina, it involves not only the upper atmosphere, the atmosphere close to the ocean, it involves ocean surface temperatures and subsurface ocean temperatures. So we'll start down low, work our way up. Again, we're looking at data from the TAO buoys array, that series of buoys strung across the Pacific, West Pacific here, East Pacific here. These are the little X's there. Those are the anchor lines. The X's are actual sensors on the anchor lines. We have a whole bunch of new sensors here that are up and running. Again, I want to see them starting to show up over here as well. But we get to see where the balance of warm and cold water is in the Pacific. If most of your warm water is in the West Pacific, you're in La Nina. If most of your warm water is in the East Pacific, you're in El Nino. Our warm temperatures here, this is 30 degrees centigrade warm water, pretty much where it was last week, about 174, 175 east. The 29 degree isotherm, about where it was, 173 west, no change. The 28 degree isotherm, hanging somewhere between 60 and 65, no change there. And the 24 degree isotherm, about where it was last week, a steady state. So La Nina, because all the warm water's in the west, but not getting any worse. And we're kind of getting late in the summer now here. You'd expect to start seeing some momentum developing. But it is not the means. That's average temperatures. It's the anomaly, difference from normal for this time of year. Now, caveat right here. Big old area of missing data. So this looks like cool water only 2 degrees below normal, somewhere under the date line, under Hawaii area, and not breaching up to the surface. But again, no data here, so I don't really believe that at all. But we do have another chart. This chart uses the sensors, but it also uses satellite data. Height of the sphere of the ocean, we'll get into that in a second, to map out what it thinks is going on. And you clearly see the warm water pattern here in the West Pacific, cold water in the East Pacific, and yes, the cool pool, not so strong here, which is a good thing. This, because all this water is moving from, gets pushed by a process I'm not going to get into the Kelvin wave thing now, but basically, it moves from west to east under the Pacific and then erupts off the coast of Ecuador. We see a healthy amount of cold water erupting over to about 150 west, so almost south of Hawaii, the whole East Pacific, big pool of cool water pushing to the top, but you don't see like some big new pool in the pipeline getting ready to come. This would be like a month or two out. You don't get the sense that there's more in the pipeline. Like maybe we're just in for one push or maybe two. That's probably too much to ask for. Let's keep going. So here's the supporting data, the sea level anomaly data. And let's just get ourselves oriented. Chile, Peru, Ecuador, Central America, the equator, the date line, Hawaii right in there. New Guinea there, Australia there. This is not temperatures. This is the height of the ocean. Use a satellite, beam down radar, strip out the wave heights, the wind waves, the tides, and is the sphere of the ocean, higher or lower than normal? And we're talking centimeters, like literally that much, okay? Very sensitive satellite. But what that means is if you have cold water at depth, cold water contracts, and then what it does is creates a divot on the ocean. Active phase of the MJO generated Kelvin waves pushing across 1, 2, 3, 4. This was number 9, the last one of the series that created our modest El Nino at best. And then here comes the cold water, the yin and the yang of the cycle, the cold water rushing in behind. You see 1 Kelvin wave, 2, 3, here's number 4, and then you see here, you get this pattern here, like there, and there, sort of, it pulses, it backs off, it pulses, it backs off. Well, here's our last pulse. Now it appears to be backing off again. That is good. And this does not look super impressive. It's certainly not El Nino, but it's not some raging La Nina, at least at this point. All right, so what's going on at the ocean surface? This is sea surface temperature anomalies, difference from normal for this time of year. South America, Central America, Hawaii, equator here, Africa over here. Cold water right out here than it was 2 or 3 days ago, but still not super impressive. I mean, you still have warm water up here along Ecuador, and just a lot of warm water from the remnants of El Nino and other processes still ongoing, sort of maybe somewhat balancing out the cold with the warm. We'll see. And not extending way out into the far West Pacific either. So just kind of where things have been, same as last week. Now, the trend for the past 7 days, 2 or 3 days ago, it was nothing but warming temperatures here. Now, we again are getting that cooling pattern right along in here. Not super broad, not super strong, but in general, the balance has been towards cooling instead of warming, consistent with a La Nina pattern. And then the overview one more time. Also notice cooling in the Atlantic. They call this a Atlantic La Nina, not very strong at all, and you still see piles of warm water up in here. It is kind of surprising that the Atlantic hurricane season has not been more productive than it has. The storms there that have been there are pretty solid given the time of year. We are deep in what should be now the main part of hurricane season, and not a whole lot has happened. One would have thought with La Nina, if it was a strong La Nina building, 1, there wouldn't be any hurricanes in the Pacific, and 2, the hurricane season would be starting to really get pumping in the Atlantic. Neither one of those have occurred. So back to the Pacific, let's look at actual surface water trends, sea surface temperature anomaly trends. This is in the Nino 1.2 regions. This is right by the Galapagos in Ecuador. Today, the value, 573 thousandths of a degree below normal, half a degree below normal. So officially La Nina, and it's not in this region, but I'll use this as an illustration point. If you're between half a degree above and half a degree below, you're neutral. Half a degree to 1 degree is considered weak La Nina. 1 to 1.5 degrees moderate La Nina, and 1.5 and above is strong. So right now, you know, and it's got to be consistently below the half-degree mark for 5 months, effectively. And yeah, we are there, but we also had a big warm spike too. Let's go look at the official El Nino monitoring region. This is the Nino 3.4 index. Notice the scale is different. So half a degree is down here somewhere. We've not been anywhere near water temperature-wise. We hit it for 1 day, and that was it. Today's value, 316 thousandths of a degree below normal, so not even a third of a degree below normal, considered in the neutral range, and we've been warmer than that for a couple of months now. The fading remnants of El Nino, or just the weakness of La Nina and not getting its foot in the door particularly strong? Unknown. This is the weekly official sea surface temperature readings. This is Nino 1, Nino 3, Nino 3.4, Nino 4. This is the one we're interested in. Here's the actual water temperatures. Here's the anomaly difference from normal for this time of year. 1/10 of a degree below normal for the week of August 14th. The week before, 0. You can see we are, we'll just go back here. You know, you've seen this before. 2 degrees, that was our El Nino above normal. And then since December, we've been steadily falling. But today, and we'll say the last 2 or 3 weeks, officially right at as dead neutral as you can get. And here we are, August, almost the end of August. That, in a way, is actually a good sign if there was some major La Nina building. So what does the atmosphere think is going on? Okay, we've talked subsurface temperatures in the ocean. We've talked the ocean surface temperatures. It is this interaction of the subsurface temperatures are your leading indicator of what's to come, and you get about a 2-month look ahead look. Then those cold waters or warm waters erupt to the surface. They have to be there for a couple of months before the before the atmosphere above it really gets a sense that, oh, something significant has changed in the ocean. Okay. This is the Southern Oscillation Index. It is an indicator of what the atmosphere thinks is going on. The difference in pressure between Tahiti in the Pacific and Darwin, Equatorial Pacific, Equatorial Indian Ocean. If pressure is lower in Tahiti, the daily index goes negative. Okay, this suggests that pressure is higher over Tahiti today. Okay. But let's go back in time. Let's see, we've got about 6 or 7 days of positive readings. But then you go back in time, we have a whole bunch of negative readings. Okay, pretty noisy, hard to pick out exactly what's going on. The 30-day average gives you more of a sense of, okay, is the atmosphere biased more towards low pressure or high pressure in the Pacific? Today's value, minus 0.28. So basically dead neutral. Where have we been the past month? Well, we've been negative basically for an entire month. No clear sign of moving to La Nina. We're about as neutral can get. There's no clear momentum in the atmosphere at all going towards either El Nino or La Nina. The 90-day average, so we'll just average it out, go the past 3 months, minus 2.24. Where have we been? Well, pretty much holding, you saw the numbers, right around 0, down maybe 2 points, something like that. I mean, we need to be down at 12 or 15, either down 12 or 15 or up 12 or 15 to be an El Nino or La Nina. So we're dead neutral. Now, that's interesting because that speaks to about momentum in the atmosphere. And, I've gotten a couple of emails like, what's going on? Where's the surf? Why is everything dead? And my answer to that is, the atmosphere has no momentum. We are neutral, and you go, well, that should mean that we're even. Everything's normal. But really, it's what I've found is it's momentum. When you're swinging towards El Nino, you get a lot of activity in terms of storm production. When you're swinging hard towards La Nina, you don't get a lot of storms, but the ones you do get can be very intense. Short-lived, not as big, but they can be intense. They're trying to poke a hole through the high-pressure bias. But when you're in this dead man zone and then seasonally speaking, we're in the doldrums of summer. I mean, summer started late in the Pacific Basin. It always does. It's always dead pretty much. Like I could almost set my watch by between July 15th and about September 15th. There isn't a whole lot going on. So you take what you can get and you start groveling because there isn't anything. So we're kind of in that place right now with no clear momentum in the atmosphere indicated one way or the other. Here's the 30-day average graphed out. You can see here's the dead zone, the neutral zone, +7 to -7, neutral, 0 right in the middle. Here was our big three, the tail end of our big 3-year La Nina. Here was the beginning of our El Nino last year, but it just like stalled in the summer. Sort of like what's happening right now, right? Our El Nino stalled. We didn't get much of an El Nino. Now our La Nina is stalling almost in the exact same place, in the exact same way. Then finally back to then we finally got some sort of a very weak El Nino signal. And then we've just been basically pinging around in the neutral zone. Here we are today, if anything, falling a little bit. Kind of looks like and smells like neutral. Here is the raw sea surface temperature anomaly forecast from the CFS version 2 model. This, again, the model has been hinting at this just precipitous drop in the month of August. So that's middle of July. Middle of August would be right about there. It says we should be down to ½ degree below normal, like within a week. I don't think that's coming. And then falling to 1.4 degrees as we get into November. And this actually has backed off. I mean, I think a week ago it was down at -1.5 degrees. Now, this is the raw data. The PDF corrected data still shows this precipitous drop. And remember, looking at the zonal wind anomaly forecast, there is a big bout of easterly anomalies coming. So maybe that will start us moving in a direction. We'll see if that forecast holds. Temperatures here going down to only -1.05 degrees, maybe 1.1 degrees, and then quickly rebounding. Now, the good news is we are past the 20th of the month, and on the 19th to the 20th of every month, they update the consensus model. Every model there is. Here are the dynamic models. Here are the statistic models. These are all El Nino, ENSO models, whatever you want to call them. Notice 0 is right here. Let's see, the red line, let's see if we can get that. That is the dynamic model average. We'll dive into this in a minute. The statistic model average is the green line right there, okay? ½ degree below normal, and the dynamic model just barely goes below that. All right, so let's go look at the details. But just eyeballing this, you go, this is barely saying La Nina at all. Or if it is, an exceedingly weak La Nina, and only from half the models. All right, so let's go. Dynamic models, August, September, October, September, October. So 3-month groupings, they do it because you don't like pick the numbers day by day. You do it on an average over multiple months. Here is all the different model numbers. Here's the CFS version 2 model. It shows its forecast. This must be the PDF corrected one, down at -1.39 degrees. We're just going to look at an average of all the dynamic models. Peak temperatures, 616 thousandths of a degree below normal in, that was November, December, January. Okay, no big surprise about that. The big surprise is it's considerably warmer than last month's, which was considerably warmer than the month before that's forecast. Statistical models, not as good. They're only saying temperatures down to 1/4 degree, 294 thousandths of a degree below normal. If you average all this mess together, it shows temperatures 0.492 below average. That's not even La Nina, if you believe that. Okay, so let's see if they can do this. Oh, I don't even see the line on here. There normally is a line for their consensus model forecast. I don't see it right now, but the short of it says, if we have a La Nina, according to all the latest data, it isn't going to be much of a La Nina. I'll take that. All right, so let's get out of the weeds for a second. Let's go look at the models real quick, or we actually looked at the models. South Pacific, not a whole lot going on. North Pacific, maybe a gale over the eastern Aleutians in 4 days. I wouldn't bet a penny on that. I think that's an aberration by the GFS model, but I think the models are hinting at the tendency towards the North Pacific coming online and the South Pacific coming offline. Tropics, actually doing way better than we expected this year. Again, hinting at weakness in La Nina and the complete stall of La Nina's development right now and in July, just like El Nino stalled out. We nearly had a heart attack over that last year. Now La Nina's doing the same thing. So that's actually good news. We don't need La Nina in the Pacific if you want to surf or if you want to ski. Looking longer term, consensus model, all that sort of thing. La Nina, the model's backing off yet even more, suggesting a very weak La Nina. If even a La Nina, we'll see. Big easterly wind burst to sort of temper all that. Big easterly wind burst is forecast for the next 2 weeks, developing starting about 3 days from now. So we're going to keep our eyes on that and see what that does and whether that's going to sort of change where all this is at, maybe add some fuel to the La Nina fire. But for right now, what was the word I used last? Cautiously optimistic, just barely. I don't want to get over my heels or over my toes too much here, but for right now, things not looking nearly as desperate as they did multiple months ago. If you enjoyed the video, give us a thumbs up. If you have a comment or question, write it up below. Be sure and subscribe. It helps the algorithm. You hit the StormSurf icon down in the lower right-hand corner of your screen. You'll get automatic notifications when the videos are posted. And if you'd like to make a contribution to the cause, of course, hit the super thanks button down below, the heart with the $sign in it. And that is it for this week. We are done. Go get some surf if you can find some surf somewhere, or maybe just work and take care of business so that when we finally do get waves, you can make use of it. All right, that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.